So let's put together a little terminology and notation. So we said our confidence interval would give correct results for 95% of samples, that once you compute the sample proportion and then make the margin of error, 95% of the time the interval will contain the true value. So we could say for 95% of samples, the interval gives correct results. That 95% is called the confidence level C of the interval. So C, you'll see that listed in tables, the confidence level, 95%, 80%, whatever. And the interval is referred to as a 95% confidence interval. So we'll see that construct a 95% confidence interval means to make an interval that works for 95% of samples in capturing the true value. The z-value 1.96 is called the critical value associated with the 0.025 tail probability. So what happened there is, when we thought about the 95%, we thought about a symmetric piece of the standard normal distribution. And then if 5% is left over, that's 2.5% on each end. And that's a probability of 0.25 as a probability. So that's the tail probability. We say we want to find the place that excludes on the upper side 2.5% of the values. So 2.5% are up here. So the upper tail is 2.5% of the values. And we write z with a 0.25 next to it to say that's the z, or above it, you're above it only 2.5% of the time. That number is 1.96. So if you want to go directly, say, from the confidence level to that 0.25, here's how you think about the confidence level. You think confidence level is 100 times 1 minus alpha, so 95% says alpha, this is how we do it. It makes sense after a while. Right now it just seems so arbitrary. But 95% is 0.95 times 100, and that's 1 minus 0.05. So 0.05 is the piece that's missing. And that 0.05 is the sum of these two halves here. And you divide that by 2 to get the tail probability, and you associate the z with that tail, that has that tail probability. You call it z alpha over 2 is that number 1.96. We call it the critical value for alpha over 2 tail probability, or the critical value, for in our case, for 0.25. Okay. And I've got a table here of some of those things that you might do for different critical values, because we don't have to use 95%. We could use any percentage you want here. And then, so with 95%, we said alpha was 0.05. That's the amount that was excluded. 95 plus 5% is 100. So 90% gives you an alpha of 10. 80% gives you an alpha of 20. So that's how much is out here when you put this stuff in the middle. So 90% is in the middle. There's 10% in both these tails. So each tail has 5%. When 80%, each tail has 10%. And then you have to look in the tables backwards, but ordinarily we don't do that because this is such a common procedure for these kinds of alphas here that there's a table of critical values based on the tail probabilities. And we'll look at that when we see the t distribution. I'll show you where you can find them on the t tables. So people that work with confidence intervals, they know these numbers by heart because they come up. 1.96, 1.645, this is 1.282, we just know them. They rounded it to 1.28. That's the critical value associated with this tail probability that you would use with this level of confidence. So if you want to make an 80% confidence interval, you're going to use 1.28 as the margin, when you compute the margin of error, 1.28 times the standard deviation. So if we can do that for any level of confidence, and here's how it works, right? So here's the z tables, here's alpha over 2 there. Z alpha over 2 is the z value that where the upper tail probability is alpha over 2. And we'll be looking at that in the future. So this takes a little bit of getting used to. We'll do some examples and see if we can make this feel a little more solid on the ground. Coming up next.